Okay, so here we are, World Wide Web, recording the second day of class on the 19th here, completing our presentation on review of the internet, and then get busy just doing HTML. Actually, we'll do even more exciting. We'll do HTML5. Yeah. All right, so here we go. We've done some of these slides. We'll skip ahead to the more interesting ones. We talked about the internet and the convergence of technology that's made the whole World Wide Web possible. Remember, the internet is not the World Wide Web. The World Wide Web is using the internet, and here is the internet, what was available to us as the platform, as the medium. Think of the road, the highway, and the World Wide Web is all the billboards on the highway, just full of billboards. But the internet is the highway that gets you there. There's lots of more things that go on over the internet, such as attacks of pages on the World Wide Web, transmission of messages have nothing to do with websites. You running your game, you're playing that game with other people. Are you on the World Wide Web when you're playing a game, interacting with other people? You're using the internet, but I don't consider that the World Wide Web.
If it's in a web browser.
If it's in a browser, maybe. But you're using, I'd say if you're using a web browser, using the World Wide Web to get to the game, running the game, I'd say, is maybe a little bit more underneath the World Wide Web, but you got there. Think of the web, I think of the web as a window into applications that can use all more capabilities of the internet. But remember all the things that went into that, where you had PCs that were affordable, where it used to be huge machines that you couldn't carry around with you at all. It's about the size of a house. The operating system was improved to allow good graphics and more usability than typing and reading text. And then not only was the internet allowed, but it was more available to your average person and is becoming more and more available with so many ways of connecting, and thus the widespread use of the web. Brought you the World Wide Web. Interesting thing that came up in our faculty meeting on Tuesday. Mr. Kozin was talking about the week of fasting from technology. How many have done that? Did you do the week of fasting? Did you find it difficult or relieving? Did it cause tension, or was something that you realized, hey, I need to do this more? What was it like for you? Was it stressful?
I just got a bunch of people who play board games the entire time.
Yeah. How about you? How about you, Patrick? Was it stressful, or was it like, hey, this is a nice change?
A nice change, I'd say.
Okay. One thing that surprised me is many people, the majority was, hey, that's a thing I need to do more because it brings in such tension and bad things into my life. Because one paper they brought up was why the Generation Z, I think is a generation you're in and maybe coming after you, is so much more depressed and anxious. There's so many more therapists needed for your generation. So if you want to get into counseling and therapy, apparently there's a big boom in that because they're saying information overload kind of thing has caused a lot of psychological problems. Some may say it's because of the development as a child that affects your way of dealing with stress. I'm not sure. What made me sad was, even at a Bible college, there is a very rare, or it's not unknown, but it's uncommon for someone to see the internet as a mission field. There are a few, he said, that they see that, they use the internet, the World Wide Web, to reach out to the unsaved. But he's saying, no, most students here don't see the internet. It's more of, it's a play area, not a serious place to do mission. So I challenge you. Maybe you can see the missions part of internet.
Because I think doing it online can often be harder because you don't really have a face.
Yeah. And so establishing relationships, it's a harder way, and some people say, no, face-to-face is more realistic, and maybe some will say you can't, it's just harder to do relational interaction, sharing the gospel in that kind of medium.
Well, these days, people on the internet, like, it's common, like, assumption. It's a common assumption that you're talking to someone you don't really know anything
Yeah, you're
about.
talking to their avatar, not to the real person. Yeah. And that was interesting. I hadn't realized that because I see the internet and I see, on Facebook, I try to throw Bible verses wherever I have a message, and I think to myself, am I showing a good testimony when I talk about things and political things or whatever discussion? Try to think, could someone accuse me of being a bad Christian by the way I say things?
You really don't want to become that guy who just posts Bible verses
Yeah.
everywhere.
Right.
Or when it's completely
Yeah.
why? It makes no sense.
Yeah. So when we're talking about like the Black Lives Matter movement, I would maybe make a comment and try to not be snarky. That's the first thing. And then find an appropriate verse. I was kind of emphasizing verses that imply, hey, God loves all races, and red and yellow, black and white, we are all precious in His sight. And it wasn't easy. It's so easy to be snarky, isn't it? When someone says something you really think is really stupid, you're not talking to them face to face. It's easy to get a one-liner against them. So I had to watch out for that because I was tempted so many times, especially some of my nephews that think they know everything because they got a degree in history, and they say really stupid things regarding historical things that they should know. And so it's so easy for Uncle Arthur to be snarky to the little nephew. And of course, your generation doesn't see the respect that the older generation expects from the younger generation. And so I wasn't involved in that, but my older sister took a lot of criticism for criticizing her nieces and nephews for not respecting her as their elder. It's like, hey, there's no younger, older on the internet. You're all kind of an equal plane. Anyway, enough of my little soapbox. Your World Wide Web is just the interface using your web servers to connect to the internet. Various standards are involved. RFC is what you hear about a lot when you're talking about the new wireless standard. They'll talk about RFC something or other. There's the other acronyms having to do with the various committees controlling the standardizing the protocols, providing some sort of guidance and standardization. This is the powerful one that controls IP addresses to DNS mapping that the U.S. used to control. In 2016, there was a big hullabaloo. They gave up control. I don't think it's caused, well, I don't know if it's caused huge issues, but remember, if you can control what people are using for DNS, you control what websites they can get to. And this is actually one way of having security. You have a DNS server that when they ask for certain sites, you send them to the sorry, you can't go there page. And I'll bet you China does that very carefully, and North Korea. Other countries are very restrictive in the internet, and part of the control they have is the DNS, which ICANN is a part of. So we're going to skip that part. We got to the part about 2022. You remember what the percentage went up to in 2022, according to this site?
It was 69%.
Yeah, up around 70%. And let's see, and that's 15% higher than 3 years ago. Let's see, 1% change in 2 years, 10% change in these 3 years. We'll see if it's exponential or if it has a plateau. I think someone mentioned because India opened up, that was a big jump. Maybe when China opens up, I have a feeling they're using the China internet. I don't know if we could call their internet actually using the whole internet.
You have to know about the survey system.
Yeah. Now remember, the intranet is a network within a company. I call it a local area network. Extranet is like a local to the company or to a group of companies networking. Call it a private network. This is the place that we go to for what the standards are, what the specifications are, and maybe there are even tutorials out there offered for you to learn things and get certified in World Wide Web. A bunch of other websites helping you out. But I'd say the more important websites for you are over here in the course resources or the syllabus. These resources here are probably the more important things for you to use. These are great places for learning and practicing and developing your skills. W3 Schools, top of the list. Great reference as well as learning. I go there often. I'll search for what is the syntax of the push button or of the radio buttons. If you're doing work for any company that has to comply, you better start following those, make your website visible and usable, or people can actually come after you for not following those standards, especially places like anything with public services like colleges, government agencies. They are more required or more prone to following those because they're public and are expected to be accessible by the public. Private companies maybe can get away with less of that, but still that's going to come. If you have skills in making sure you're following these rules, you will have good job security. The universal design idea is you make your web's pages accessible to everyone, as large a range of people as possible, including people of different languages. Think of how you do that. That's why you see icons on many sites along with the text. And many pages you can choose the language to view the site in. Sometimes the language of your browser is detected and it will automatically show your page in your default language. They're saying this road cut is an example of universal design. Not only does it help the people on their segways, but people in wheelchairs or people that can't step up curbs very easily. Getting the information, this is your problem, and all your searches and research, where do you get the reliable information? The COVID years made it very clear to me that your view of the world depends on where you're getting your news. Even before COVID came along, your view of the world depends on where you're getting your news. And news people know how to manipulate your perception of the world. It's just a fact of life. They manipulate your perception by telling you what is important to know. Just think of it. And that's been the case ever since news organizations have ever been around. The powerful news people can manipulate anyone into what's the important things. And if they just ignore a story, everyone else that reads them thinks, oh, I haven't read it in the news, it must not be important. Okay, now getting into the more technical part of this. This is the stuff that you need to have a really good handle on when you're dealing with computers talking to each other. They're communicating through packets of information going across the wire. You've all had basic networking, right? I'll take the basic networking course. So you've covered a lot of this. I want to be sure that you're understanding what's happening at the server side. We're going to take a little peek into an actual working server just to give you a real good understanding. Remember, you can have a server anywhere on the network, a local server or a server out there across the internet that is connected through its router, through its modem or transceiver or through satellite. You're connecting to that server either through a long path or a short path. But what the server does is respond, typically on port 80, to a request for a web page. And how does the server know what page to give you? Well, it's based on the request information sent from the client through the network. Let me get my little laser pointer to make this even cooler. From the client over the wires in a packet. How does the packet know how to get to your server? What's the first process for your client to know how to get to this server named joe.local or joe.com. Say he's going to joe.local. How does your client know how to get to server over here if this is joe.local?
The switch typically has a bank of the MAC addresses to send things to.
Okay, so there's a MAC address of this guy. This switch knows about, and when you go to him, he knows. But how does he know that that's the MAC address of the server?
It asks it.
It asks. Who does it ask? Does he know the MAC address at the start?
No, it asks,
I want to go to joe.local.
It sends it to everyone asking if you're this person.
Correct. There is a, hey, who's got this address? But wait a minute. How do I know joe.local's address from this client? He wants to, this client visits joe.local. How does he know what the IP address of joe.local is?
Well, for the MAC address, he's do ARP.
No, we haven't got to the MAC address yet. How does he know?
DNS.
Yes, that's what I was looking for. He has to actually ask his DNS server, oh, I'm looking for joe.local. What's the address of joe.local? So there is some DNS server out on this network. It's not showing. I'll say maybe the DNS service is also running on this server. You can have many servers. One server can actually serve DNS as well as serve websites. So that service could be running. So what actually happens on the network is this client says, hey, I'm looking for joe.local. Are there, hey, main DNS server. Remember in your IP config what your main DNS server is? Default. Remember that command prompt? You do IP config. You'll see your default gateway, but then I do IP config /all, and I see that my DNS servers, I ask, hey, I'm looking for joe.local, what's his IP address? That's what happens first. DNS request, he gets, oh, joe.local is at a certain IP address, sends a request, hey, who has that IP address, where are you? This guy responds, and then this MAC address is known in the response back. Then the messages are known by MAC address. So there's a little bit of a negotiation for what's the MAC address, and then a session can be established. Hey, joe.local, please send me the home page. Same thing happens if it's joe.com. The DNS server says, hey, joe.com is at a different IP address on a different network, and who knows how to get there except my default gateway. I know where to go when I want to get to an IP address that is not on my local network. The router says, oh, I know how to get there. I'll go get and send messages to joe.com. So DNS resolves to an IP address. IP address resolves to, in this case, the local, the MAC address of the local server. In the case of an external address, it resolves to the MAC address of your router. And I know when I send messages to joe.com, I'm asking to send a message to the router. He'll know how to get to that external server and return the page back to me. So client request and response, getting a real good handle on that protocol. A great way to see that is actually start Wireshark and then do a request for an IP address and actually watch the Wireshark traffic. Maybe we'll do that one time, but let's get to building web pages first. Let's get this theory over with. So let's just go take this a little further, make sure we understand what's happening here. I request joe.com, that's more interesting. I get the MAC address of my router saying, oh, I know how to get to joe.com, okay. The client says, okay, send me, after DNS tells him the IP address of joe.com, and then he sends a message to that IP address of joe.com, getting out through a transceiver or copper, whatever multiple paths will take me across the internet cloud. Somewhere there's a path to joe.com, a unique external IP address, through his router into his server located likely at a server farm. It may be in the little phone room of Emmaus, if you go to people.emmaus.edu, but it came through the satellite. Somebody knows where people.emmaus.edu is located, because I can do a lookup of a name, and it shows me the IP address. Okay. The data, or the server, is more likely to be in something like this, our server farm. I have been to a tiny one located down in Marion, Iowa, just this side of Cedar Rapids. It's a warehouse, just rows and rows of racks with fans running incessantly, and it's fairly cool. It's comfortable but very noisy because all these fans running. And you walk down the aisle, you see the back side of servers, on the other side is the front side of servers, and every server has a lock, and when you need to service one, you have a specific key or combination to that one specific server. The one I was in actually had blocks of the servers and fences around parts of it. So I could only go into a particular area in the server farm. It wasn't open like this huge one here. I don't see any doors at the end of the lanes of servers. But in a secure one, you have a control room. You can only get through into specific parts of it. But imagine the electricity that these kind of server farm requires. Multiple generators, backup generators. It'd be fun to just see what their electric bill looks like for a month. But there's your server farm, and somewhere in there, the router sends the information to the specific server that has that particular IP address of the website you're visiting. It sends back the HTML back through the session that you've established with it, and your browser client displays whatever that server sent back to you. Along the way, anyone can sniff your traffic. Even if you're visiting a secure site with HTTPS, they can still tell where you're going to. They can't see the data if it's encrypted, but they know you're visiting Moscow.net. They know where your message is going. So even though you think, okay, they can't see my message, they know that you've sent a message and are talking to a particular server, and that's where the darknet comes in. They make it harder to trace the calls through the dark web. So remember, your LAN is your local network. The WAN is the public wide area network across multiple geographic areas, going through multiple mediums like satellites or cables or phone towers. And this is kind of interesting, the actual internet backbone. Let's take a look at what the internet backbone looks like. There are maps you can get to. I'm going to go back to the other one. This one's more interesting. You can actually see, you can actually see the cable map of the cables in the oceans. I thought this was kind of interesting.
But can you go to Indonesia?
What's that?
Can you go to Indonesia?
Indonesia.
It's in Southeast Asia.
Let's see.
Oh, yeah, well, Australia.
Well, there it is. The main connection to Indonesia. Now, I'm not sure how updated this is. It says updated last January 9th, 2023. It'd be cool if you could actually see the traffic graph.
Hold on. What's that one right there that splits off and goes into the middle of the ocean?
The Indian Ocean here?
See how it splits off there?
I think there's a tiny little island there, yeah.
Okay. Just like, hold on, what's there?
Wonder how much they paid for that one little... I wonder if the cable actually runs there and back. This seems like a silly path, but...
Is there any that lead to the Bermuda Triangle?
Let's see. Lots of them going through there. And lots of parallel. And actually, when you zoom in on this, you can actually see what name of the cable it is. They all have names. And I don't know what you get. If you click on them here, oh yeah, look, you click on it, takes you to that particular cable. I hadn't played with that before. Oops. Each cable, it gives you the length and who owns it. Oh, so it's owned by different entities there. So Aquacom's between here. So kind of an interesting map of all those connections. I wonder what the whales think of all this. Do you think they're being affected by this?
Any that lead to Antarctica?
I don't see any.
There's 4 scientists.
Yeah, they got to go satellite.
Yeah, I've heard internet down in Antarctica is really, really bad. You only get internet certain times of the day.
That would have to do with perhaps the sunspots and things affecting the poles. If they're doing satellite, I can see that affecting their transmissions.
I think it was more of the where the satellites are located.
Oh,
'Cause
right. Yeah, they're equatorial.
Yeah, why would they want to
Yeah.
send satellites down there?
And some that do circle the poles are moving. They're not in a fixed position.
It's like, because a lot of the scientists down there are like funded scientists for certain researchers.
So I'm hoping by now you have a really good sense of the client and the server concept. The client is your browser. The server is what sends back the web page. The client is anything that requests information from a server. The server sends back the request. And server is a very general term. It doesn't just have to be web server. It could be the print server. It could be anything that is provided by that server as a process. A print server, a mail server, make up a program that provides a service and it's a part of the servers. So your request is sent, here again, through that DNS. I get the IP address, but I also have to tell the IP address, by the way, when I come to your site, I am looking for a specific site on your server. Remember, your IP address of your server is most likely not going to be just one website. Typically, servers serve more than one website. So you have to tell the server, oh, I'm looking for this site on your the web page for a particular site, and you could also add a subfolder of that website. If you don't have a subfolder, or if you don't specify the actual file name, your server is configured to look for a default file in a certain order. Typically, index.html is your default web page. If you're using PHP, your default page that looks for it is index.php. And there's actually an order. You could have different ones there, and there is a search order that you can configure in your web server. And what does your server do? Well, it's based on what you're looking for. It follows the instructions or simply pulls up the static HTML page and sends it back to your client in the proper format that your web browser decides to view. So let's take a quick little peek at this configuration of the server side, just to give you a nice understanding of this. I learned it best by actually having to set up a server, but I'm not going to make you set up a server. I'm going to take you to mine. I'm going to run putty.
Buddy.
That does SSH to my server. Where are you, buddy? Here's buddy. I'm going to connect to my server, people.ms.edu. People. I don't use port 22. I use port 1313. Never use the standard port. And up pops accept the signature, and I'm going to log in and see if I can remember my password. And I'll make my font a little bigger for you so you can read what I am seeing. Oops, what I am seeing on my settings here, and change my default settings, the appearance of my font, make that nice and big, go. So I'm going to go to my server, and let's go to where the config files are. CD, where are config files on Linux? Top level config files for Linux.
What?
Config.
For
What directory do they typically reside in
what was it?
for Linux? For any program, where would you typically go first for configuration files? What location? Etsy, that's your config file location. And then underneath there, it's typically HTTP, and underneath there, it's well, let's tab. What do we have there? Oh yeah, we have conf.d. Conf.d is the directory of configuration files. And in there, I'm going to look at sites.conf. This is the Apache configuration that most people use. In sites.com, look what we have. When someone comes to my IP address and says, I am looking for moodle.emmaus.edu, I say, oh, I know where to go to look for the files associated with that IP address. That's the configuration side of my server. There's a virtual host entry for every website that this particular host uses. And you'll see the people.emmaus.edu one is right there. When I come to visit people.emmaus.edu at my IP address, my server knows, oh, when they want to visit that address, here is where the files are located. So this is the default location of the files for various websites. Some of them are registered. I know People is registered. I don't think these others are registered, but I can put them in my local DNS file under Windows System32 drivers etc host file. So this is what's happening at the server side. It knows there's an IP address associated. Well, you know there's an IP address associated with people.emmaus.edu, but my server needs to know. Well, you're coming to my IP address, but what site do you want to see on my IP address? That's what's encoded in the request to my server. So this is typically a server does not just serve one website. It serves multiple websites. Okay, enough of that. Just some fun stuff, just to give you a peek into the server side configuration.
Does that have a public IP address?
Yes. If I do IP address at the server, my public IP address is also has a private one on the staff side. Here is my public IP address right here. Here's my public IP address. You can actually visit that address and you'll get my default website. Let's see what happens when I visit that IP address. I'll copy that and I'll come up to my browser and paste that address. There is my default page for that server. Every server has a default site. Typically your default site is, hey, you don't know where you're going, check your address. It's a security issue to actually visit a site just by IP address. You know why that's a security issue? If somebody just gives you an IP address of their server, that means that they have randomly put out an IP address. They have an external address, but they haven't registered with any DNS. Sometimes that means they're a sketchy organization. They don't want to, or they are prevented from registering with DNS because they're a sketchy organization. So it's generally frowned upon, and some firewalls will actually not let you visit websites by IP address, because any fly-by-night person can set up an address. They can even attempt to even use my external address and have ways of fooling you to come to theirs. But usually that's a little harder to do because IP address conflicts are a bad thing out there. So your server will have a default web address. If I do people.emmaus.edu and my DNS host file hasn't been poisoned, it'll take me to, oh, I spelled Emmaus wrong. It'll take me to the actual site. Look how exciting that site is. Wow. I haven't done a lot of work on that website. I do have sub pages of that. And there I have. Oh, there's an exciting website. Lots of cool stuff. Maybe I can work on this website for our class here. Spiff it up a bit. Okay, back to our presentation then. You're using multiple browsers. Now the browsers have gotten better at being standardized, but if you're building a website, you need to make sure it works in the browsers that your customers are going to use. And I guarantee you, as you get more complicated, one browser is going to break and the other will work just fine. And it'll be so frustrating to you. And the worst thing will be if your customer finds out before you do that it is broken for Safari because they just love Macs and you never tested it on that browser. And suddenly you look very foolish because that person with a Mac is the CEO and was doing a presentation at the point where they're ready to write you a check and your website is bad because they were using a different browser. So your client is simply a program asking for pages from the web server, receiving them, and rendering them. Some of these browsers are very forgiving in poorly formatted web pages. They'll look just fine, but you need to make sure you validate it because it can break with bad times. What's that?
So they're not Internet Explorer.
Yeah.
That doesn't render anything.
They're using Internet Explorer at times. There are the browser wars. It's always interesting to see. This has me confused. What do they mean by mobile? Because I know mobile devices, you can choose different browsers. I have Chrome and Brave on my mobile device.
I mean, mobile does usually have its own settings, though.
Yeah, so
There's usually a mobile version.
right, but I use Chrome on my. I would think they might say Chrome Mobile or Brave Mobile or maybe their particular Verizon Mobile. But this has me confused. Why they seem to be clumping together all the mobile browsers. But anyway, you see, Chrome is still the winner. Edge, Microsoft sure likes to try to conquer the world, but never seems to quite make it.
Literally annoys every single person in the entire world. You really should use this program. Everyone else, no, I want Google.
Opera is kind of sticking along. You know, there's that Opera user base. Safari, Apple has certain things that work best with Safari. It's not dropping, but it's not huge. Firefox just does not seem to be doing very well.
Yeah, sadly, it looks like ever since 2011, it's been below Chrome.
And then Explorer, I don't know why Microsoft just keeps. Well, we know Edge is trying to beat out Explorer, but Edge is not making a big rise.
Wait, when was this made? When was this published last?
It looks like 2019, 06-2019.
So here's my question, right? So it says it's on a percentage basis, right?
Yeah.
So, given the fact that more people have been using the internet more and more, I wonder if something like Firefox, that makes Chrome's climb more impressive.
Yeah.
But I wonder if that makes Firefox's downfall more of a flatter curve, because I
Right.
assume most people who are using
Right.
Firefox.
Current users.
I don't think very many people who are
Right.
using Firefox are switching, but I
Yeah.
could definitely imagine not very many people joining Firefox.
And there's places you can go look at the analysis of the browser wars. They might give you more details about all this information. But it's kind of interesting. Remember though, if your customers are Edge customers, it doesn't matter that it's only 5% or less. They're your customers. You have to make sure it works for them. So you may have fewer, but those are maybe your paying customers. Fortunately, they're getting better at working together because there are standards out there that people are following. Microsoft is, in my mind, the biggest culprit in making their own standards and ignoring the rest of the world because they're such a big company and they can decide that. But I think they're learning, maybe people just don't really like us because they know if they start using Edge, certain things will only work in Edge, and it'll be so annoying for people that use Chrome and that page just doesn't work for them. Now, I'm not going to spend a lot of time on the server. Let's start writing some code and make sure you have a good handle on HTML.
Apparently, Samsung Internet has 3%. Never even heard of that.
Yeah. Oh, one thing as we finish up here, they mention in the book FTP protocol, and I think a big warning there: do not use FTP or Telnet. Just make it a practice of using secure FTP and secure file copy. When someone mentions FTP, it's like, where are you? What were you thinking? You do not use anything that is not encrypted. FTP is the very, very, very last option if you're working with a really old insecure server or transmitting stuff that it's completely nothing secure. FTP is not secure. If you ever use FTP and you lose something, they're going to come after you because you should not have used FTP. So just make it a practice. Don't use Telnet or FTP unless you're just working with equipment that just, there's no other way. But FTP is a way. Back in the day, they used to transfer files. Now they use secure FTP, which the great way to do it is you can use basically tunnel it through SSH. That's how I do it all the time. WinSCP is the program on Windows for using secure FTP. There's other protocols that have to do with the internet. I'm not having you worry about that. You'll learn about that in networking course. Want you to have a good handle on your client-server interactions. Let's see if there's anything here. Well, HTTP is just